Hello, algebra students, Mr. Lawrence here, as if you didn't know. And before we get started with this lesson on polynomial expressions, I want to give a couple shout outs here. Aiden, I know you've been participating a lot, and I love how you participate. Keep up the good work, buddy. Josh, you've really been working hard. You know, at first I wasn't sure. You seemed like kind of a quiet kid, but lately you've been coming out of your shell. Keep it up, man. You're doing great work. Kristen, oh wow, I told you in the hallway the other day how proud I was of you, how much better class is when you are participating. Keep up the good work. Jake, man, you're always ready, aren't you? You've got your work always done, always ready to participate. You're always very polite and kind to your classmates. I love it. And Chandler, I wanted to thank you for that awesome way you described how you knew a linear equation when you said when x increases by 1, y increases by a constant amount. It's an awesome definition. This is why we got to learn from each other. This is why we got to help each other. We got to listen to what other people say. Remember when I'm talking, when I'm talking to a student, you have to imagine I'm talking to you. You have to think, geez, how would I answer that question? Maybe you have a better way. Maybe you have a more thorough way. Maybe your way is not as good, and so you listen and you can adjust your way based on what you hear somebody else say. All right, let's get down to this. We're talking about polynomial expressions. No, Dylan. This is not when you are punishing your parrot and you decide to not give it any dinner. No, that is not what a polynomial is. A polynomial expression, before I actually define it, I'm going to take us back on a trip back to elementary school. And I know you all know how to read this number, 3,145. But do you all remember, this is the ones place, right? And this, of course, is the tens place. The 4 is in the tens place. And then the 1 here is in the hundreds place. And then the 3 is in the thousands place. Right? Okay, well, can't I rewrite this number? Isn't this the same as 3 times 1,000? Right? Aren't there 3,000s in this number? Plus 1 times 100, because there's only 100 in the number, right? Plus 4 times 10, because there's 4 tens, that's what 40 is. And then there's 5 times 1, because there's 5 ones. Polynomial expression is going to kind of look like that. I don't know if you realize this, but we use something called base 10. And if you look at these numbers here, the 1,000, the 100, the 10, and even the 1, they're all 10 raised to some power. Well, like this one is obviously 10 to the first power, right? Then 100 could be 10 to the second. 1,000 would be 10 to the third. Well, then, of course, what would 1 be? Well, it would have to be 10 to the 0 power. And I know some of you had a hard time with that. Non-zero numbers raised to the 0 power are 1. But there it is, demonstrated again. So we're in base 10. Now, in polynomials, we'll be using base x. Base x. Okay, it's an unknown base in that case. If I don't tell you what x is, you can't put the number in, but it's going to behave very much the same way. We might have x cubed terms, x squared terms, x to the first terms, and even x to the 0 power terms. Okay? Now, polynomials are made up of monomials, but mono down here, mono just means one. Okay? That's all it means. So it's just one term. And poly over here means many. So an example of a monomial, I'm going to write a monomial here in blue. Here's a monomial, 5x to the 4th. That's a monomial, okay? But if I take another monomial, like 3x squared, and I add them together, now I have a polynomial. Typically, if there's 2 terms, we'll call it a binomial, because bi means 2. And then when you start to add 3 or more, that's when you get poly. So I could add on here, plus 7x. Here is a polynomial, okay? polynomials are made up of many monomials connected by a basic operator. Okay, so let's take a look at a couple examples. We're going to classify them here in a minute. All right, I'm going to write down 6x to the 5th. Over here, I'm going to write a negative 3x squared plus 2x plus 5. And then let's go with 10x to the 17th plus 5x squared. Oh, let's make it minus. What the hey? All right. Oops, you know what? I have multiplication there. I really shouldn't. I should just have addition and subtraction. Sorry about that. Okay, so what is this term here? What's that? What's that, Julia? Yeah, you're right. That is a monomial. Nice job. Give yourself a little pat on the back. Okay, good job, Julia. All right, this one here. This one here. I know, Lainey knows what this one is. Lainey, go ahead and tell us. Absolutely, this is a polynomial. And, you know, Lainey, I know you're so smart. You're thinking, hey, Mr. Lawrence, there's 3 terms. Can we call it a trinomial? We sure can. We sure can. It's a type of polynomial. Poly means many. Okay, usually, I think I said 3 or more before. I meant to say 4 or more. Okay, 4 or more. But we'll call it a trinomial. All right. And then let's see here. Let's call on a boy for this one. How about Adam? Adam seeing 2 terms. Yeah, that's right, Adam. You got it. It's a binomial. Binomial. Okay, now with our polynomials, we like to write them in simplest form. Simplest form is the way I've written them here. Okay, all the like terms have been combined, and we tend to write them in what's called descending order. Notice how there's an x squared there. There on the x, there's an x to the first, and then this technically would be x to the 0. The powers are going down. Now I normally won't put this x to the 0 in there. It's there if we want it, but it's unnecessary. But it's important to see that the exponents are going 2, 1, and then 0. Okay? On this binomial here, they're in descending order. It's just that we don't have any x to the 16th terms, x to the 15th terms, etc. all the way down. We just have x to the 17th and x squared, and I write the higher power first. Okay? If there were 12 terms, I just take the highest power and I'll put them down as they go. All right, now, polynomials can be classified 2 ways. One way is by the number of terms, and we've talked about that. We had monomial, that's a fun word to say, which is 1 term. Okay, for example, like 7x to the 4th. That is a monomial. All right, by the way, just a plain old number like 12, we'll call that a constant, because there is no variable component to it. It's just a constant. It's always 12 until it's acted upon by another number. Okay, and then we have a binomial. Excuse me, do you have any binomials available? And binomial means 2 terms. Okay, so for example, 5x plus 1 is a binomial. 8x to the 4th minus 3x is a binomial. There's also the trinomial, which was just mentioned. Whoa, it's really taking off. A trinomial, which is 3 terms. Okay, so like 2x squared plus x minus 5. That is a trinomial. 12x to the 4th minus 3x cubed plus x. That's a trinomial, okay? And then after that, we call them polynomials. Polynomials. I'm sorry, Polly has been a naughty parrot and does not get a meal tonight. No, a polynomial. Poly meaning many. So you might have 5x to the 7th plus 3x to the 6th minus 4x squared plus 1. 4 or more terms makes it a polynomial, and yes, one of the terms can be a constant. Okay, it can be a constant in a binomial, in a trinomial, or in a polynomial. All right, now we also classify them by the highest exponent. Okay, and we just say degree 1, degree 2, degree 3, etc. So if we had like 5x to the 4th, okay, that's degree 4. All right, but it's important to recognize that some of these classifications. Okay, and some of them are a little bit more important. Like if I have 5x to the 1st, that's degree 1. But a first degree polynomial is a linear polynomial. Linear, yeah, that word's familiar, right? Well, if we stick it in an equation like y equals 5x, and we made a table, we're going to see that the first differences are consistently increasing by the same amount. And if we were to graph it, it would produce a line. But remember, if we graph it to produce a line, isn't really, it's a good working definition, but it's not a good reason. It's that the first differences are increasing by the same constant amount. If we have something like this, x squared plus 2x plus 1, okay, that's a trinomial, right? But its highest power is 2. It's a degree 2. But when it's a square like that, we call it quadratic. Yeah, there's a quadratic. Okay, so when the highest power is 2, it's a quadratic. If you tried to graph that, y equals x squared plus 2x plus 1, you would get the parabola. But again, that's not a good reason. I mean, let's see what happens if we make a table here. X and y. Okay, let's take 0, 1, 2, 3, and 4 in. Normally I go 1 through 5. I'm going 0 on this one. Let's see what we get. Well, 0 ends up being 1. If I put 1 in, I'm going to get 1, I think 4. When I put 2 in, I'm going to get 4, 4, I think 9. 3 is going to give me 9 and 6, 15, 16. And then 4 is going to get 16, 8, 24, 25. Okay? Well, my first differences end up being what? Plus 3, plus 5, plus 7, plus 9. And there it is. The reason it's quadratic, the second differences are all, plus 2. Right? The second differences are all increasing by 2. That's the reason it's quadratic. Okay, so let's look at a degree 3, because it has a special name. A degree 3 polynomial would be like x cubed plus 1. And notice the degree doesn't affect the number of terms it has. This is a third degree binomial, but I could have written a third degree trinomial or a third degree monomial. Okay, this is cubic, and that's an easy one to remember because 3 dimensions. A cube has 3 dimensions. And I'm not going to talk a whole lot about the graph. We'll do those later. But I wanted to mention to you, as a cube, third degree cubic, 3 dimensions, length, width, and height. Okay. In the quadratic, we get a graph of a parabola, something like this, right? And in the cubic, we get this part of it, but let's see if I can do this, right? This part here that would normally come from a quadratic, this part here, because our exponent is odd, actually gets flipped downward like that. And so it looks like the quadratic, only about some point here, the vertex, one part of it has been rotated downwards 180 degrees. Okay, so that's what a cubic's graph will look like. Now, by the way, if you made a table, where do you think the differences would start to repeat or be constantly the same? I'm not going to tell you. Let's see if you can, make a table. See if you can come in with this tomorrow. You got x and y. Okay, and then pick 0, 1, 2, 3. You're going to have to go a few more. You might have to use a calculator for this. 5 and 6. Fill in the y values by putting 0 in for x cubed, 1 in for x cubed, etc. And then go down to the difference and see where they repeat. See if you can tell me, okay? It's kind of cool. Now, one last one that's actually named is when you have a 4th degree polynomial. So, for example, you might have x to the 4th, 5x to the 4th minus 3x cubed plus 2x. Oh, I don't want to do that. Plus 7x squared minus 8x plus 12. Okay, that's a 4th degree polynomial, and that is called a quartic. Okay, that's a pretty complex equation. We won't be graphing anything like that, but it will have a very parabolic shape to it. It'll look not too much just like unlike a quadratic. Okay, quartic, I think of quarters as 4. That's how I remember 4. So therefore quarters, quartic. Okay, so we've classified polynomials by degree and by the number of terms that they have, right? And so you'll definitely want to be familiar with these terms. Okay, we talked about monomials, right? Polynomials is one term. Binomials, trinomials, polynomials. Okay, so 1 term, 2 terms, 3 terms, many terms, 4 or more. And then we also talked about classifying by degree. Degree 1 was linear. Okay, degree 2 was quadratic. Degree 3 ends up being cubic. And degree 4 ends up being quartic. Okay, anything above quartic, you can go ahead and just say degree 5, degree 6, degree 7, etc. For these first 4, I'm going to get you to use these terms as much as possible. All right, that's it for the video today. Mr. Lawrence signing off. Have a good night, everybody.